for a shortcut. We've done product rule. We've done quotient rule. Now the last of the shortcuts, chain rule. You need to get used to seeing this particular notation, and I see a slight typo already. There should be another parenthesis in there. But basically, you've seen f of g of x before. You know that kind of means one function was put inside another function. That's really what that means. G of x was put inside of f of x. And if I want to take the derivative of that, we've been given a rule over here that basically says to take, kind of the derivative of more the outside, leave the inside, then take the derivative of the inside. That's kind of how I look at that. For example, this first one here, if you wanted to talk about this first example as what would f of x be and what would g of x be for this situation, I would look at f of x as being x to the third and g of x is x squared plus 1. Do you agree that essentially this got put in there and then cubed? Right? That's really what happened. Okay? One function was put inside of another, and that's what really happened here with this first setup, right? Okay, now I don't need you to separate f of x and g of x every time, but I need you to understand that it is one put inside another. Okay? Now the tricky part of this is why isn't there an x attached to that one right there, that f prime, right? That's kind of the weird part. Okay? But look at it this way, is if I just took the derivative of this f of x, we know that would be 3x squared, correct? But what we're saying is, why don't we just do the 3 part and the 2 part? We know that. That's part of taking this derivative. But what's in here? What's taking the spot of that x? All of that, right? So that's what they're saying. So here's 3, here's your g of x, and squared, right? Isn't that really what they're saying with that first part? It's f prime of g of x. And then I only got one more thing to do. Take the derivative of the g of x, right? So here's kind of how I look at chain rule. So yeah, then again, we would just take it times the derivative of the g of x, which is 2x. So that is your answer, but let's kind of speed things up a little bit. What really happens, I'll take care of the left side, y prime. What really happens, and this is very helpful, because let's face it, do we really want to sit there and cube that? Take that times itself 3 times and then do power rule? Because you could, right? Okay, that's why this is definitely a shortcut, because I definitely don't think we want to do that by definition. Basically, you take that 3 times whatever's out front, which is an understood 1, right? So 3. Write down the inside, so there's your g of x. Take it down a power. So that's really, if you look at it, that's really this portion. It's not f prime of x, it's f prime of g of x, because you're sticking g of x in there. Okay? So that's what we've done so far. Now times the derivative of whatever that inside part was, which happens to be x squared plus 1, so the derivative is 2x. Now, can we do any cleaning up? Well, we can a little bit. This 3, can I distribute it into here? Not really right now. Why? Yeah, because it's squared, right? You have to follow order of operations. But can I distribute that 3 to maybe some other parts? Yeah, I can take this 3 to the 2x. How come? Yes? Yeah, very good. What somebody said is when you deal with multiplication and addition, it doesn't matter what order you do things in. And that's actually one of the properties, correct? The commutative property of addition and multiplication. Very good. So I'm going to go 6x. Well, now that it's 6x, can I distribute it to the x squared plus 1 squared? No. And at this point, we could multiply this all the way out, correct? But a lot of times we are going to set this equal to 0 or set it equal to something over here. So isn't the factored form really the best form to have it in anyways? Okay, it is. So that's why a lot of times we are going to leave our derivatives like this, because that's the most usable form. Because let's say if I had to go to my graphing calculator and graph that right now, could I just type it in like that and graph it? Yeah, so why multiply it all the way out when I'm probably going to want it back to this form anyways? Doesn't make any sense. So this is the chain rule, kind of one function put inside another. Okay? So you can probably see that this is very helpful when there's something in parentheses to a power, right? And so this one, I think we actually did one similar by the definition, correct? That wasn't very fun, if I remember that one. Okay. We had to do the conjugate and do various things. So we'll take the derivative of this side, so that's f prime of x, got that. So how can I rewrite this so that I can actually use the chain rule on it? Yep, same thing we tried to do with the power rule, right? Write it as x plus 5 to the 1/2. So now what do? Well, is this actually a function put inside another function? It is. F of x, if you want to start looking at this as the square root of x, and g of x is what I put in there, which is x plus 5, right? I mean, if you want to look at it that way, you can. Right? So really, I would say, well, here we go. There's a 1 out front, so that's how we would take a derivative, so 1/2. What does it say to do at this point? The rule says to basically write down that g of x, or that function that got stuck in there, right? So x plus 5. Be very careful here. It's very easy to forget taking this down a power, and a lot of times you just don't write anything is what gets people in trouble. Okay, but then writing the wrong thing also trouble. What should I put as the power? Very good, -1/2, right? Down a power. And then times the derivative of the inside, or g of x, which is 1. Now you may wonder, why do you always, I always actually write that there, because then if I look back at my problem, I notice, oh yeah, I did take the derivative of the inside. So you don't think, oh, I forgot, and then do the problem all over. Right? So we can clean this one up a little bit, make it look a little neater. Well, we got a fraction involved for sure. What really would be fine with remaining in the numerator? A 1, right? That's about it. What about that 2 right over here? Is that 2 all right? Well, it's on the bottom. This technically is where right now? The x plus 5 to the -1/2 is really in the numerator, right? Where does it really prefer to be, though? On the bottom. And is it okay if, well, I'll write it in a couple steps here. Right? Which is that. Right? Again, either of those are probably fine. But I would probably personally prefer that one. Well, that's way faster than the definition. Okay. So why don't you try one on your own without any help? Obviously, we could multiply this one out. It really wouldn't take that long. Or, why don't you just give that one a whirl? Well, let's see how that went. So the derivative of the left side, y prime, 2x plus 1 to what power? The first. Very good. And again, I do actually write the 1 for the derivative of the inside. So really, the derivative is, really, you could write it as 2x plus 2. Because I can actually distribute that 2 because it's to the first power. Right? There it is. All right, determine the derivative of this. So somebody said they really wanted to go back and do some by the definition.
I got it.
So that person can go and do that now while we do the shortcut. So notice I'm just putting an equals here. So am I taking the derivative at this point? No, what am I going to do? What do you mean separate it? I'm not really going to separate it. Nope, I'm not even going to do that. What they said is figure out what f of x is and what g of x is. I'm not even going to do that. I'm just going to rewrite it. Yeah, so here we go. X squared plus 2, not to the 3/2, but the 2/3, right? Because it's already to the second power, the third root, correct? So it'll be 2/3 power. Exactly, somebody just said if this particular 2 was not there, it would be 1/3. Okay? So now do you notice how chain rule can be very helpful on this one? Initially, it didn't look like it was going to help at all. But now we rewrote it, and so here's where, Algebra 2 is really starting to pay off if you paid attention to Chapter 5. So understood 1, so 2/3 times 1, 2/3. So that's kind of the f prime of not just x, but of g of x. So that's why we write x squared plus 2 down again, because that's kind of your g of x. Now, very easy to mess this up. It is 2/3 power. Should become -1/3. Times the derivative of the inside, which is 2x. So you got to take that derivative of whatever you got put into that other function. This one might take a little bit more to clean up, but we know we got a fraction involved. So there's definitely a 2 on the top, along with a 2x, correct? So a 4x that's going to remain on top, a 3 that's going to stay on the bottom, And then all of this other stuff is going to be very good. Once I move it down there, it'd be a positive 1/3, right? So it'll be x squared plus, 2 to the 1/3 power. Now what about this radical business in the denominator? Yeah, we're in calculus. So basically now can you see why we leave it there though? Because what's most common number I'm going to put over here? 0. So then I'm going to take all that stuff and multiply it up and it goes away. Okay? And so that's why we kind of leave it down there. Because it's really not affecting us. Okay, so there you go. Well, that's way easier. And in about 2 or 3 days, when that other person's done doing it by the definition, we'll see if we get the same thing. Okay. So here we go, g prime of x given that. Now, this particular problem could be done another method. This could be done in quotient rule. But I can use chain rule because it's a constant on top. Okay, if there was any variable in the numerator, we would not be able to do this. I'm once again going to rewrite it as -7 times 2t minus 3 to the -2 power. Seeing that numerator was just a constant like that, I just have it sitting out front. If it was a -7x sitting there, then we would have chain rule inside of product rule. If we did it the other way, we would have chain rule inside quotient rule, which is going to happen. Maybe not today, maybe not tomorrow, but someday, soon. All right, so here we go. Multiply them. That's a good arrow. What do we get? Thank you. 14 times 2t minus 3. Very easy to mess up. -3. And then for some reason I have another set of parentheses. Derivative of the inside, which is 2. Derivative of 2t minus 3. Yeah. All right, what do we got here? 28 over 2t minus 3 cubed. Again, let's not lose what we're finding here. We're finding a derivative which is going to give me the instantaneous rate of change at any t value that I want on the original. And all I have to do is substitute it into the derivative. Or really, at this point, I could put a particular slope that I want to find over here and find out what t value would give me that slope. And probably the most common one we want is 0, and you'll find out why as we go throughout this year. Questions so far? Oh, look at that. No, I said maybe. Not today. All right, so here we go. We do actually have two functions that are multiplied together. They are x squared and the square root of that. And it may be very beneficial to write it this way, because this is going to be chain rule inside product rule. And here's where product rule actually becomes much more beneficial than it was last week when you use it with chain rule. Okay? Because am I really allowed to distribute this in? Unfortunately, I am not allowed because it's the 1/2 power. So we're going to look at this as being my first function, and this one over here is my second function. All right, product rule, here we go. Write down the first one, which is x squared, times the derivative of the second one. This is product rule. But you notice to take the derivative of the second part, I need to use chain rule. Okay? So to take the derivative of just this is 1/2, 1 minus x squared to the negative 1/2 times a negative 2x. Because I did chain rule as if this was the only problem I was given. Okay, so the 1/2 times the 1 out front, and then I wrote it down, took it down a power, right here, took it down a power, then took the derivative of the inside. Okay? I'm being told to write down a plus. Why a plus? Which rule? The product rule. So I did write down the first one, take the derivative of the second one, right? So now plus. You told me to write a plus. Now you write down the second one times what? The derivative of the first one. Do I have to do the chain rule to do the derivative of the first function? No, what rule is that I'm going to use? Power rule. So it's just 2x. Isn't this awesome? All right, let's clean this up. We have two terms right now. We got that term there and that term there. I use squiggles so that it doesn't look like division. Do we have any questions before I go on? Where did what come from? This one over here? This is the other part of product rule. This was write down the first one, derivative of the second one. This is write down the second one, derivative of the first one. Right? First one, second one. Right here is chain rule. When I took the derivative of this one over here, was chain rule. Just part of that was chain rule. Okay. Now there is something that I could show you algebraically right now, but I'm thinking that chain rule inside product rule is probably enough of the magic today, so I'll show you that another day. So let's just clean up this term that happens to be on the left over here. It is all multiplied together, but we do know that it is going to be a fraction in the end, because we got some stuff that's unhappy at the moment. So let's start off by moving that. So that's going to be down here. Yeah, under a square root, right? Is there anything else that's going to be in the denominator? Okay, I'll write it there for now, but it's not going to end up staying down there. But I'll write that 2 down there, that one. It's not going to end up staying there. But. So that's gone. And on top, I've got that and that, so negative 2x to the third. Okay, so we'll just go step by step here. There is one more thing I can do there, but we'll leave it at that for now. So plus. Is there a fraction over here? Not really. Just 2x times the square root of 1 minus x squared. And I'm going to wait, let that absorb for a second. Just letting people absorb this for a second before, because this is really 2 times all of that, right? And this is 2 times all of that. So really those do cancel. Okay. So in other words, that. Now, technically, one thing I'm not having us do today, because I don't know about you, I don't really want to set that equal to 0 right now. Okay, I would probably get a common denominator if I was doing this, but I'm going to let that go for today, because I want you to be able to just for today get that chain rule just happened inside another rule, and this is when truly product rule gains power, is when you pair it with something else. Yes, we will go over actually 2 ways of how to finish this another time. Yes? For right now, I'm good with this. But again, I don't think any of us right now really want to try and set this equal to 0 and solve that mess over there. Right? With 2 terms over there, probably not, right? But we could substitute in an x value easy enough, though, right? If I knew the x value, we could substitute that in nice and easy. Right? Okay? Yes?
Okay, so before we get to the negative 2x cubed.
Yes. Mm-hmm.
So 1/2 times 1 minus x squared to the negative 1/2. That all went down the bottom.
Okay, the question is, so hold on, the question is here, that all of this went to the bottom. Really, the 2 went to the bottom because that's where it was anyways. And then this was unhappy with being in the numerator, and so it moved to the denominator.
So you took x squared times negative 2.
I took, yes, this was still in the numerator, and so was this. Yes. Yep. hmm That is a lot. If you were to walk in on that right now, that'd be a little dizzying, actually. Yeah. Okay. Questions other than that? There was another one, or did that answer it? Okay. We good? And, hey, last page, all right.